Hello guys, today in this video I would love to explain you how to draw the fiber to the X schematics in QGIS. If you work in the telecom industry, probably you have been fortunate to witness this type of schematic produced in various applications, not necessarily the GIS software, but I mean rather Microsoft Visio or other tools where this type of schematic can be done. In this case, I would love to share my knowledge and show you how your job can be done quicker and more convenient by using QGIS. So let's get our hands dirty and see how can we do this stuff. In front of your screen, you can see an example of cable schematic diagram which has been produced in Microsoft Visio. And first thing which comes to your sight is a multitude of pentagons connected by the lines. Obviously, everything represents very important telecom infrastructure characteristical for the given job area. If I do some small enlargement, you can see pretty much how it looks like. Obviously, the graphic pattern is custom. It not necessarily must be produced like this, but I will stick to this particular pattern as shown in the given document. This type of schematic is the final output of my QGIS work, which does look great, and admittedly it strongly resembles the previous one. If you could compare the graphic side of both documents, there is not that much difference. Basically, I did some smallish alterations. I changed the text orientation mostly and adjusted it towards the general shape of the schematic. I did similar stuff for the following pentagons either. Each pentagon represents the important point across our telecom infrastructure. This point can be OLT cabinet, it can be primary node, secondary node. So this type of telecom infrastructure are represented by points which are connected by lines. These lines are cables between them, which can be underground or overhead. They are mostly underground. Okay, so you know pretty much how the final version of Fiber to the X schematic should look after work in QGIS. So now it's the time to show you our work literally from scratch, from the telecom project as it exists in QGIS. So this is the whole telecom project which has been done in QGIS. It's comprised of quite a lot of layers available in the panel on the left, as you can see. Let me expand them a bit. So this whole low-level design, which already you can see in front of your screen, must include also the fiber to the X schematic, which usually comes as the final step of this telecom work. So in this case, I will lead you through all the steps from the situation as you can see right now, where you've got pure low-level design, to the final PDF file which you could see recently. So let's get started then. Bear in mind that your final product from the view you can see here will be the straight line diagram as presented in the following PDF document. So this is pretty much your final result, the final result of your work. Let me close this document down and get started. At the first glance, we need to take a look at the layers panel on our left hand side and try to read this panel. I don't mean read each layer one by one, but I mean read the layers rather by type instead of by name or shape or color. And we will finally get into conclusion that all these layers can be grouped at some point within just two or at most three types of layers. In the straight line diagram purpose, just two types of layers will be required, and it will be the point layer, which you can see already. I am highlighting some of them, and we will also need the line string, line type of layer, like this kind of layer. All right, so at this moment the process could be far simplified than we could have thinking at the very beginning of this process. Alright, so if we already decided that our FTTX schematic will be comprised of just two types of layers, we need to select what types of layers. Now we need to select exactly what certain layers will we need for our schematic. So we will definitely need, let me expand this area slightly. We will definitely need inline splice closures. We will also need secondary nodes, primary nodes, OLT cabinets, and basically all the point layers are done at this moment. And another group will be the line layers, line string being precisely, and it will be covered by fiber allocations, both overhead and underground. Alright, so we have pointed out 6 layers which will comprise of our whole straight line diagrams, and they will be split by geometry. So as you can see, they are already grouped. So occasionally, if it's some problem for you, you can move them out from that group, but you don't really need to do it so, because everything can be done exactly from the step where we are. So the primary step here will be merging these layers, cutting down the number of these layers to the lowest number possible, which in our case will be just 2 instead of 6. We'll effectively have all these layers merged within line string and point. So let me do it. Firstly, I will merge the line layers. So I will go to the vector data management tool and hit merge vector layers. In the input layers, I will show the fiber allocation underground and fiber allocation overhead, and click OK. Destination CRS will be the British one, and we can temporarily create the scratch layer, see how it will work. Right, so our layer has been already merged, so effectively we have received the layer which basically covers all the lines essential for our straight line diagram, all the cable routes. So now let's do the same for all the point layers considered. So let me point them out again. Primary nodes, secondary nodes, inline splice closures, and OLT cabinets, wherever they are. Again, vector, data management tool, merge vector layer, and instead of 2 layers, we'll already have 4 layers put here. So they will be OLT, inline splice closures, primary nodes, and secondary nodes, right? So we've got 4 layers to be merged. And the step here looks exactly the same. We've got project CRS, British one, and hit run. However, now we are encountering some error, which means that some of the fields aren't compatible between each other. So it means that eventually all these layers cannot be combined between each other. That's sad. However, we can fix it quite quickly. Let's go through this error. So THP field in the layer secondary nodes has different type than other layers. So THP is string instead of integer. So how to combat this problem? First of all, we need to remember or write it down to which particular field and layer this error refers from. Next, we need to use the refactor tool. So THP field for secondary nodes. So in processing toolbox, we need to select refactor fields. When we have the refactor fields window open, we must choose the most problematic layer from our point of view, which will be secondary nodes. When you see this comment, just go yes, reset everything, and now take a look what's going on. So we've got the THP layer, which is marked as the string. So the type of string is wrong because THP represents the numbers only, so we need to change it to the integer and simply run the algorithm, which will save our job as the separate scratch refactored layer. So let it happen. As you can see, the layer has been created, and now we need to go to the vector and data management tool again, merge vector layers. But now instead of selecting secondary nodes, we will select the refactor as the first. Then we can leave the secondary nodes because this layer is already wrong. We will select primary nodes, OLT cabinets, and inline splice closure. So we've got these 4 layers required for the another part of our schematic, and repeat everything as previously and run the algorithm. Now everything is alright because algorithm has been finished, so it wasn't any issues on the way, then it's fine. So finally we have 2 groups of layers required for our straight line diagram. They have admittedly the same name, but we will recognize them easily because one of them is line, another one is the point one, yeah, as you can see. But what we can do right now, we can use the option move to the top, and in this case we will have both layers required straight on the top. However, it still requires moving away from the group because the layer is placed within the group. So this is what I told you at the very beginning. Once your layers are grouped, then it's good to move them away from the existing group and place them completely on the very top. Alright, so we've got something to start from right now, and it doesn't look encouraging at this moment, but you can see in fact some changes which already happened here. Our view still looks like initial. We've got our work project. However, some new layers appear right now, but we don't need all of them. This is the key moment here in which we should literally get rid of all other layers which aren't considered for our further work. It applies admittedly to all the layers down from the group presented here. So there is a quick way to switch all these layers off. First of all, we can use the tool provided here and we can just click hide all layers. If we use this option, depending on the size of your work project, we need to wait a bit and QGIS should switch all the layers off, keeping the blank canvas likewise as creating the new project. Alright? Now we need to restore the layers which have been already created for the straight line diagram purpose, which are these two layers only. As you can see, we've got line layers and point layers which have been already merged into just two layers. So again, from 6 layers considered for our schematic, we've received 2 layers in order to keep our job nice and tight. Alright, so in this case, important is to take a look on the data attribute table and see what is happening there, because data attribute table already includes the stuff which is comprised of all the merged layers. So let's go through slowly all the columns, and some of them are completely empty. We won't need them at all. We will base our selection on the existing data. Path basically is not needed, so I will go and remove. Alright. So let's consider this layer name is quite protracted from my point of view, so we need to find some solution in order to keep it more simple. Like you see, I believe we won't need this first part of the string at all. So with this help, we can use the field calculator and use the function which will replace the string with the other one. In practice, we'll replace our part of the string with nothing. So let me do it right now. So as I said, there is a function, not regex replace, simply replace, which will supersede our string with anything we want. In my case, with nothing. But because this name is quite long, I cannot right now copy it. So I will close it down for now, double click on it and execute the piece which I want to get rid of, which will look like this. So basically everything before inline closures I need to copy, Ctrl C, and paste to the field calculator and bound everything with function replace. Everything will fall in the bracket. Replace, define the column which in our case will be layer, press comma, quote everything, another comma, and simply quote with nothing, yeah? And as an output preview, you can see that it will look pretty much like this. Alright, next, update existing field and choose layer. When clicking OK, everything is pretty much fine. However, we still have another problem here because as you can see, layer throws refactor instead of type. So here instead of field calculator, I will use select by expression tool and I will type, for example, OH/UG. It's not null. And I have already selected the stuff which needs to be fixed, alright? Because the layer is refactored, I need to transfer the type to the layer. Or you can do other way around, it's not a problem. Because at this moment I can just invert selection and I will have pretty much the same effect but towards the other side. So let me stick to this current situation, select the type. Now we can open the field calculator and simply use the name of the given column. Like I did here, layer refers to the column which is already here, update existing field type and will surely be done just for the highlighted blue selected features. Hit OK and currently we have everything in place, alright? So we can remove the selection and our merged layer here is ready. So we can hit save and browse the attribute table from the other layer. Surely we also have columns not necessarily needed, like column path which is already here. So the first step will be removing this column and the situation looks pretty much the same. However, I admittedly chosen wrong option because here I don't have type, I have layer only. So after reducing the string, I will work on the layer section. So I will back to the previous layer again and change it to the layer, but slightly later. Now repeat the process with situation like here. Before I run the the field calculator. This prefix is not needed. In the field calculator, we must repeat the function, replace bracket, double quote, layer, comma, put our prefix into the quote, comma, and quote with nothing. Close the bracket. We should receive the name we want and update the existing layer as the layer. Alright, let's see what is happening here. It does look correct, doesn't it? So we can just save it and close it down. Okay, so as I said, with respect of this layer here, instead of type, I must transfer this type to here, because I will work eventually on the layer column instead of type. So basically, in my select by expression, I need to type layer is equal to refactor. Now I have the stuff selected, so by running the field calculator I can just only press type and close it into the quote and choose the layer. My data from type will be transferred to the layer. Alright, so in this case I don't really need the type column, I just need the layer column, but I can keep it for now, just in case. Anyway, we'll work on the layer column in both cases. I hope that you understood everything until this point, because this situation completes another step with FTTX straight line diagram preparation. Alright, so it seems like everything is so far so good with our layers. The data attribute table has been sanitized, so I think we can kick off the next stage, which will be making this view more like straight line. How to do it? So I think only the line, the cable routes can be stringified right now. We can do rather nothing with the point layers, with the nodes and infrastructure. So the function here is vector, geometry tools, and we have nice option which is simplified. In the simplified, our input layer will be merged. We don't need to worry about the other layer called merged, because as you can see, we are dealing predominantly with line string. So I'm sure that it will be this layer. But if you are not confident enough, you can always change name of this layer or save them previously. Simplify method can be distance, but now tolerance 1 degree doesn't look great. So what we should do with this thing, I think essential is saving our layer first, because we cannot really operate on the temporary scratch layer right now, because the layer is not reprojected. We will get the tolerance in degrees. We don't want that. So let me close this window down, and at least this layer should be exported. Because GeoJSON throws error. I don't understand enough why it happens like this, but I discovered that the safest method of saving remains shapefile. Shapefile cuts down the length of columns to 10 characters, but with the layer column should be still fine. So before we choose the name of our file, it's good to select the coordinates first, because if we stick to the WGS84, the units will still come with degrees, because this coordinate system is general for the whole world. We need something more detailed. So in this event, we need to stick to our coordinates we are working on. The CRS will be British National Grid, and the file name, let it call like cable route, for example, and hit OK. It should appear quickly in our layers panel. Alright, so our cable route is already here. So by repeating the process, geometry tool, simplify, and cable route, as you can see, tolerance is not in degrees anymore. So we can keep meters, but it won't be 1 at all. It may be something higher, 25 or even 30. Let me go with 25 and run the code, which will execute another layer called simplified. So this simplified layer reminds the straight line diagram much more than previous layers. So what does it mean? It means that before checking the data attribute table, which I am doing right now, and I see that everything looks pretty much the same as for previous layers, I can simply get rid of the previous linear layers. So by removing both merge and cable route, I am having the simplified route, which now should be saved correctly as the cable route final. Everything remains in place. We don't need to change anything. Just export this layer to the correct extension. Don't keep it as the scratch layer, because we can lose it. And just in case, we can do the same with merge. We don't need the scratch layer anymore. So let's repeat the process, reproject this layer. The CRS is now set correctly, same as the format. We can call it like infrastructure, okay, and save. Alright, by checking the attribute table, our layer column is unscatched because it's shorter than 10 characters, which is very well. And cable root final, again we can check the attribute layer, but I can't see nothing suspicious here, which is great. So the merge layer can be removed without hesitation. And in this event we are rounding off the next step. We've got all the layers prepared, and moreover they are simplified enough to build up the straight line diagram, but it's still quite a lot of work to do. Okay, now I have a very important step in front of my eyes, namely a wide understood styling. What is it for? The styling is the quintessence of our straight line diagram. We must do our best to stick as much as we can to the provided PDF version produced in Microsoft Visio, probably, which looks like you can see right now. Cable routes are marked with different colors. They have obviously labels, and the infrastructure point layer is represented by pentagons. Same here. Alright, so we must stick to the pattern like you can see right now and adjust the styling. Basically, it's not that complicated thing, but it takes quite a long. However, fortunately you can use this style over and over again in QGIS as long as your project is pretty much the same. You don't need to worry about styling that much thereafter, only for the first time. So let me start with infrastructure first. So infrastructure, let's go to the properties and let's go to the styling. So I won't use single symbol. I will use the categorized version, where for the category I will use the layer. Symbol will change. It won't be marker like you can see here. It will be the pentagon. Alright, so select the pentagon, hit classify, and this is pretty much what I want to have. All other values can be removed because there's no other values here. So I think I have all I want, just need to play with the coloration. So it won't be much hassle, but let me apply it and see how it looks like at this particular moment. Alright, so we've got some pentagons, but they don't look very nice. Let me use the scale which is here. They are too small, so another thing where I need to certainly apply for them is changing the size. So maybe size is not that important thing that as unit itself. Unit cannot be millimeters here because we need to use map units here, and this map unit will define the real size of the element under the proper level of zoom. This is obviously the thing which you need to play with. I can't assure that it will be correct or not because everything depends on your particular needs. It still looks quite small, so let me apply the bigger size, for example 5, and see what will happen this time. It looks slightly bigger but still not big enough, so in order to simplify this process, because for this moment I just need to change the colors and set the object size. So because I have this file download, I will use this file right now. In the toolbox you've got nice tool which is set layer style, so you can choose the layer you want to style, and my layer will be infrastructure, and style files can be found here. So the style files are saved in the type of QGIS layer setting which is QML file, and because this is infrastructure I will select the PN which corresponds to the point layer, primary node, and I will hit open. Hit run, wait a minute, and suddenly my point layer is being styled correctly. So, because I haven't run you through the whole styling process because it would take ages for this video, but just for quick recap I will show you how this style looks like, and it will be the inspiration for you for the next time. So symbol again, it's the pentagon, size be 15, and unit map units, opacity keep us 100, which is great. Then coloration is valid for all the particular values which firmly stick to the PDF provided. But a part of the symbology is styling. So styling is also important thing because styling determines the label. So as you can see in the PDF you have the information about the THP, information about the ID of the given object, as well as the information about number of liters provided. So effectively we have three types of information here. So that's why the labeling is important, and the labeling can be found under additional section which is labels. So you have the rule-based labeling and three basic types of label used. By opening each of them, we can check all the details, and the most important detail will be the filter and value provided. So in this case, it's just quantity without any other formulas, and the text color and so on. When we enter THP, we can see that the value is more complicated. Apart from the pure value from data attribute table, we can also find the prefix, which is the string basically, and it's been quoted as you can see right now, and concatenated with the current value used for determining the THP value. And the last one is the name, which comes from attribute table again, and the color has been determined also for this purpose. So this is pretty much how the styling looks with respect of labeling. And it may be still something which could draw your attention. Namely, you have two types of categories which fall exactly in one place. Sometimes situation like this may occur, that we have two different values which must be placed in one location. Therefore, we need to arrange some order for this categorization, which is presented here, and we need to have this order right in order to not overlap wrong shapes. So in this case, the order is correct because, as we can see, the inline splice closure, which has smaller symbol, already overlaps the midspan overhead, which symbol is slightly larger. How to do that? So let me go back to the styling again, hit the right click, go properties, and where we have the categorized styling provided, then we need to look around what is happening beneath of the general symbol ramp, general list of our categorized styling. Namely, we have some options here, like advanced, where you can define the symbol levels, but this option for this case isn't important as much as this option here. So let's go to the layer rendering, which is the most important, and you've got the arrow here. This AZ is probably something which you might know from Excel, for example, or other tools, which symbol means that something is ordered. So if you hit the AZ, then you must define the values which can be descending or ascending. So basically this is the right location of determining the order of your categorized styling, which will be translated to your situation as you can see right now, in order to make sure that the symbols fall in right position against the whole schematic. You need to use the option which I told you before. So this is pretty much how the infrastructure can be styled in QGIS. Obviously the file in this case has been provided, but going to our other layer, which is cable route, we can style this cable route in QGIS. So bear with me, I will show you how to do it. Before I start tiling this cable route, let me jump to the attribute table again and show which data I'm going to stick to. So cable size will be the primary criterion here, which is clearly defined here, and another one is the layer, but because the layer name seems to be too long for me, I will use wildcard, and you will see this wildcard in the expression provided, which is the percent symbol in QGIS. So I hope that you got this point right now. Let me back to the styling, go to the properties, and the category styling won't be the best option for now. So I will use the rule-based styling, and in this rule-based styling, I will provide the symbols which I already need for my cable. So bear with me. Alright, so this is the first formula I will use, like I've shown you before. Cable size, this is the name of the column from attribute table, and 12 fiber is the value. So we use the double quotes for the column name, we use the single quotes for value. Alternatively, you can just pass the name of the column without any quotes. However, if you've got the space, it's advisable to use the quotes here. Then we need to meet two conditions. One condition is the one which you can see here, and end statement means that two of them must be valid in order to execute the given criterion. So the cable size must be 12 fiber and layer must finish with something like OH. So as I said previously, this is the wildcard. So by bounding the piece of our name within the quotes and using wildcard, we are going to hit this condition. So now click OK, and we've got the criterion defined. Now we can jump to the symbol and define the symbol of our layer, which will be pretty much something like this. Also make sure if you are going to use the same symbol across more than one layer, you can just copy the HTML notation, which is far quicker operation than fiddling with these values here. For the time being, we can assume that this color is okay. Stroke, we can go with 0.7 or 75 will be slightly bigger. These options of customization are quite advanced, so we can leave them for the time being and start to create another criterion, right? So hit plus, provide the label, and once the label is provided, go like previously to the filter and hit the expression symbol and repeat the process known from previous situation. And finally, I have the second one. However, I made small mistake because the F letter is small, it's not capital, so I can easily change it and hit enter. Done. That's fine. Go plus and provide another value. This is the situation which I told you previously. You can use the column without quotes. However, as you can see, the space means that only the cable comes through, size not necessarily. That's why we have to put the column name in the double quote. Right, so we've got everything which is overhead. Now we can jump to the underground cabling with the same coloration. Alright, and now I have the color, but leave this color for now. The quickest method will be clicking on this attribute and just copy symbol. Here, paste symbol. That's why of how we can get both coloration and thickness the same for the other criteria. Alright, so it looks like we have defined the styling for all types of cables which will be used in our schematic. Now we can hit apply and make it in use. Our legend already has changed. As you can see, it has been applied here, but because the project itself is quite large, we need to wait for a while, and our schematic has changed layout significantly. But it's still not everything which must be applied for the cable route styling, because as you can see, we have no labels provided. Therefore, I need to go to the properties again and instead of symbology, select labels. Labels will be rule based because I have three elements to show on my cable route. First of them will be cable length, where in the filter I will define the proper formula for this cable length. Function is format number, which will keep my length as a number regardless of its shape and cooperation with string. Format number will bound the length expressed in meters, which will be rounded to 0, so no decimals will be provided. As you can see, output preview has changed from 0 to 65, which means that I'm on the right track. However, it's not everything because I need to concatenate and provide some suffix meters. Then it's fine. I will have output expressed in meters. You can put the space, it's up to you. Just keep the space and you have separated the meter values from numbers. Hit OK. Make sure that you are fine with the text. I will change it to blue. Size is fine for me. You can always change it later. So this is the first one which I provided. Let me go with another one. Cable size. Now I don't need to put any filter because I have cable size in my attribute table, so it should be fine. Hit OK. And the last one will be also simple. The last one will be cable ID. It can be also used from value. Cable ID. Hit blue. Hit apply. And see what will happen now. We should have some labeling provided. Alright, now as you can see, the labels came out, but it looks quite messy here, so it means that we need to make some workaround. First thing which might draw your attention is the general readability of these labels. when I zoom them out, I see that they still appear, so it's wrong. So I need to go back to labeling and define the minimum and maximum scale as it has been done for infrastructure previously. So go to the properties and you have the options like here, minimum scale and maximum scale. So our minimum scale, let's define for all of them scale range. So minimum scale, let's make it optionally 2000, and maximum scale, let's make it 1 to 1. And let's repeat it for all of them. Hit apply and see what happens. Now all the labels are gone as our scale is lower than 2000. So if I change the scale, like you can see here, I've got just pure tiling without any labels. When I zoom in, labels appear. That's kinda right, but with respect of cabling, we still have plenty of things to do, especially with respect of cable ID, which seems to be too long between the single elements. Moreover, they tend to disappear when zoom out, so it can't be like this. We need to go rendering and select the option like this. Show all labels for this layer, including colliding labels. Repeat it for each of the labels. And now should be fine. But if I zoom in, we can see another thing which may be awkward, namely the idea of our cable, which doesn't look neat as the name is extended from one element to another. So I'm personally unhappy with it, therefore I would like to change it as quick as possible. For this reason, I will jump to the cable root final layer and define the rule for my label. If I open the labels properties here, I can clearly see that no significant rules have been applied to any of the label elements provided here. That's why I shouldn't expect anything spectacular apart from seeing the one extended string from one end to another. But it's going to be changed right now because I would like to provide another formula which will tidy this whole bit up. I will start from the cable ID because it appears to be the longest one. So by double clicking on the given label, I can open the additional options, and in the section of value where I have the pure cable ID, I can provide the more sophisticated formula which will break this text apart between 2 or even 3 lines. So the current formula should look like this. We've got already reget replace function where we are gripping the cable ID and we are defining the place where our text will be split. But it's not at all what we should do here because now we have to visit the formatting section and in the option wrap on character we should put the colon here. It will assure us that the division will take place, and now is the time when we can click OK and simply approve our addition. What has happened now, as you can see, our string has been split by 2 lines, and it does look slightly better, doesn't it? We can obviously play with it and define the other line where we could split our text. Even without changing the formula provided here, we can simply revisit the formatting section and instead of colon provide the slash, which as you can see here occur more often in our ID string. Alright, click OK, then hit apply and await for the changes. And admittedly, I can think that this representation is fair enough for me. The text is tidy. Obviously, it overlaps a bit the other one when zooming out, but remember that we already defined the lower level of zoom for our text appearance. Therefore, it should be gone when zooming out more. So this particular formula will definitely work for us, but it's not at all. We can play with the other ones as well. I think the cable length should be also provided here because so far we have no value provided to the cable length. Our value will be the length in meters, but the principle will be the same. Since we get the length in meters, let me hit OK and hit apply. you will see what will happen. We should receive just the pure number showing how long is the given section of our route. On top of that, it overlaps the name ID, which is also not good, but as you may have noticed, the length is expressed just with the numbers and a multitude of decimals, which we certainly don't need. Therefore, we need to go back to the labels again and define the other formula, this time for the cable length. Alright, so in the value, I will provide the specific formula which will clean our text up. Another hint, if you see that your formula is highlighted red, it means that something is wrong. Like you could put already, I've provided the apostrophe and everything looks alright because my formula is already black again. Alright, so by clicking OK and hit apply, I should see the format desired by myself, with clear representation of the cable length. But unfortunately, it's still something wrong here because I don't want to have the cable length displayed on the same site where the cable ID is. Therefore, I need to go back to the label again and play with it more. This time I will visit the placement and in the allowed position we'll click below line. That should be fair enough. Something has changed, but it looks like the other value has changed instead. Yeah, because I hit the cable size, that's why. Because cable size is 48 fibers, so the cable size came under the line, whereas the cable length remains still on top of the line. Therefore, I need to go also here, and again, in the placement, hit below line instead of above line. After clicking OK, I should be happy with my definition because both cable size and cable length will appear at the bottom, whereas the cable ID will sit on the top of the line. That's perfect. So I think I'm fine, and this is admittedly all what we need to do with describing of our cable routes in the straight line diagrams. The final output should look pretty much like this. Don't worry about conflicts with the other labels because eventually we will use the other scale for rendering our schematic for the printing purposes. So I think this is now the time for another step then. Or maybe not yet, because I think this is still another smallish step which we could do here, very small alteration, which could be applied optionally when I go again to my labeling, and for the cable size and cable length I could provide the other font. Instead of style regular, select the style bold and do the same for the cable size. That will look smarter, at least in my opinion. Yeah, here you go. Alright, so now it's definitely the time for another step of our work. Namely, what could we do right now? By looking at our schematic, we can see a significant difference between the overall shape of our work and the shape of work which shall be expected at the very end. The one thing which tricks our eyes is the straightness here. We've got a lot of straight lines perpendicular and parallel to each other, and this is admittedly the goal for the nearest moment. Our schematic doesn't look like this. It's quite chaotic, randomly located bunch of points connected with various lines. This is how I could describe at this moment, but we can simply change it. The primary step which we could do here is providing grid. Grid can be launched from the processing toolbox and from the vector creation, where we can select the create grid option. By double click, we have obviously some types of grid. Our grid type won't be the point, it will be the line. Horizontal spacing, as default it comes 1, but we won't use the 1. I think in our case will be sufficient to use 25. Another very important element here is the extent of our grid. We can set our grid extent by the layer extent definition and pick up, for example, the cable route. When done, the coordinates of our job should appear here. We don't necessarily need to worry about the CRS because it comes as the default for our CRS project, and we shouldn't be worried at all about saving the grid because we can work on the temporal scratch layer for the time being. By hitting run, wait a moment until the grid appears. When algorithm finished, you should have see grid populated here. Optionally, you can change the color, but you don't really need to do it. Now, since we have the grid, we need another feature which will be very useful for our job, namely this panel here, snapping toolbar. Snapping toolbar, which can be launch from the view toolbars, snapping toolbar. This is the one, yeah. In the snapping toolbar, we have the snapping option, and we also have the option for our all layers. We can set it for the active layer, and our active layer will be the layer already toggled in the editing mode. So it will be the infrastructure and cable route final. Since we have these two layers toggled in the edit mode, we can use this particular feature, which is the vertex tool. In the vertex tool, we are using the vertex tool for all layers. And now what we can do, we can simply move our elements towards the nearest grid node where they will be snapped easily. Alright? Unfortunately, I use QGIS 3.12 where the mandatory step is to move the given layer at least once. Therefore, at first glance you may need that this option doesn't work, but it obviously does. As you can see, in the given section, for the first time I have to move two layers separately, but the next time I can pull them together, alright? So this is the way of how we can make our diagram straight, like the straight line diagram should look like. As you may have noticed, where the point icon was doubled, it didn't appear until you save the layer. So if the situation such as this will occur again, just simply save your layer and it will come out. Let me show you on the example also here. Like you see, the second symbol is gone, but if it has been saved, it comes out. Alright, so this is the way of how you can work on it. There are two things which we can modify on the way of preparation the schematic, namely the snapping tolerance, which you can see is already been set at 25 pixels. What does it mean? If, for example, I try to move the element from here to there now, if I would like to place another one in the vicinity, I cannot really because it's been snapped already to the nearest line, which falls quite far from the element. Alright, so in order to avoid the situation such as this, let me show you on the example like you see already here. Imagine that I would like to change this position from here to there. I can't because it's been snapped to another line, so I can simply change it by decreasing the number here, which can be applied like 5 or even 4, 3, something like this. Then I could make my changes without the problem, like you see already. It works correctly. And another element is the scale. As you may have noticed, the scale has been set intentionally at 2001. Why values such as this? Because previously we set the scale for our text appearance up to 2000. So everything which falls beyond this scale is invisible. Why is it for? Because we want to have our QGIS running smoothly for the job purpose. Imagine that I will now take a closer look and zoom in. you will see that my QGIS will significantly slow down. That's why I decided to set the scale to 2001 in order to have my map as much detailed as possible, but have an instant and easy access to the snapping points easily, which fall roughly where the grid lines cross. So the pivot thing here is finding the balance between the good access to the snapping points, which fall roughly here, and the level of detail offered by our current map. Because the most important thing which we need for now is providing smooth work without any freezes, stacks, and so on. So when the QGIS slows down, we are irritated and we might be eventually distracted. Alright, so let's keep our scale as it is at 2001. In the other way, we can zoom out, is not a problem, unless we do not cross the 2000 number here. Alright, so finally I've get to the point where the whole schematic has been straightened. So that looks nice, if I could be honest. So what I could do now, the first thing is taking grid off, because we don't need them anymore, and see how our SLD diagram resembles the one presented in the PDF. Let's take a look at the PDF version right now. If I, for example, bring the PDF version in front of myself, I can see quite serious similarity between the job I did and between the PDF document which been done by someone before in a different application, probably Visio. Right? So now I can take you to the other step. The next stage of our work is shown after we zoom into our diagram below the 2000 scale, which allows us to show all the labels up. And it's not difficult to see that the labels are oriented in various directions, driven by the cable routes, linear layer, in other words. And this label position, same as cable routes, impacts the labels defined for nodes, the point layers, which can be seen like, for example, here. We've got effectively 5 cable routes going from this in-splice closure. It's not difficult to find the other examples, even adjacent ones, where usually a few or at least more than 2 cable routes go from the given node, the given point item. Therefore, we need to find some solution for it, and I will show you something extra which already has been applied to the other schematic, very similar to this one, and we can carry on our presentation from the other one from this moment. But before I jump to that one, I just drag my mouse and show you how the problem looks like. I can change my scale only a little, however, it's clearly seen everywhere. Alright, so let's jump to the solution for it. The solution for the problem presented before might sound quite funny because it's called SLD alphabet. Why is it called like this? You can see we have quite a few single solutions which are expressed by the proper label position typical for the given situation. Like you can see the example A, the most simple one, because we have just one cable route going from the node and therefore the text label can stay as it is. B example is slightly different because the text must be rotated. Example C, we need to pull out a piece of text to the left or to the right, and so forth and so forth. So eventually we have most of the alphabet letters used for it. All these situations are translated to the appropriate expressions applied to the labels, which I'm going to show in a minute. In fact, I will be back to this SLD alphabet a few times in order to get you understood this whole process correctly. So now I've got the other schematic opened and quick look at the situation. You can see that all the labels have been rotated correctly, at least in the viewing area so far. But let's go to the labels conditions. We obviously have rule-based labeling, and if I double click on one of the rule, I can go to the placement and I can find the section which have been defined already manually. If I go to the rotation, I can click edit and see what variable has been put here. The variable is rotate point. From where does it come from? The preview is 270, so let me open the data attribute table. Maybe in the data attribute table you can find the stuff considered already in this setting. So to the existing attribute table, I've added some relevant columns, which are rotate point, rotate label, and configuration. The configuration firmly corresponds to the SLD alphabet presented here. Like you see, the configuration corresponds to the specified letter expressed in this attribute table, except of A, which obviously is a default configuration with label, which doesn't require any changes. So let me go back to the label settings and open up the rule analyzed before. When I reach the placement, I can see exactly what section has been modified manually by myself. It's the rotation where I applied rotate point. This is the name of the attribute table column, which shows the example below 270. Expected format is between 0 and 360, which is fine. So we can go back and see rendering should be fine. We must remember about this particular option, which allows us to show all labels for this layer, including colliding labels. Maybe for the scale used for printing out this schematic is not that necessary, but sometimes in order to make sure that none of our label will disappear accidentally, we must keep this option selected always, all the time. Go back to the second rule. The second rule can be slightly more complicated as it may require some expressions for the placement. Like you see here, expressions have been set. Let's open them up and see how the things look like. And obviously we have some set of conditions based here. When the name of attribute column called rotate label is 90 and configuration is B or configuration is I, then our offset will be 8, which is exactly below right. Okay, so let's go back to the B or I, and we can see that the THP text is pulled out to the left. And same for the example I should be, but the example I isn't rotated on the same way as the B is. Again, other example. When rotate label is 270 and configuration is G, then our offset is option 6, which is below left. Let's go back to the example G and see how it looks like. This is roughly situation presented here. Okay, this is just one part of our conditions because the second one is defined in the offset. The default offset is X and Y. According to the Cartesian system, X means that we are going right, Y means that we are going up, assuming that our values are positive. But expression has been defined also here. If I click edit, I can see another bunch of expressions, and at the similar basis, I have the offset X and Y defined individually. So I won't replicate my discussion from the previous expression. I think you pretty much know what's going on right now. The offset X and Y plays quite minor role because it's confined just to the visual appearance of the label, and it must assure us that the label doesn't collide with another label in the nearest vicinity, and everything looks neat. But the principle is exactly the same as previous. So we've got the second rule discussed, and the most intriguing rule is the longest one, which is the name. Again, like previously, if we go to the placement, we will see both quadrant and offset defined. When I open the expression here, hit edit, now I should see slightly different conditions, but the rule applied is analog to the previous label statement. Again, we have the particular combinations listed here with the given conditions applied. Let's see how it works for the first example. When rotate label is 90 degrees and configuration is B, or configuration is J, then we have 1, so the label should be above. Let's see how it looks like in our example. B or J. In both cases, the name falls above the point feature, which is fine. But in J, the text is rotated, but it's still above the node, right? The third example should be the same. So maybe let's go with the second one. When rotate label is 90 degrees and configuration is A or configuration is O, then condition is 0. So 0 means that it's just above left. Let me back to the example I and see, is it above left? Exactly, because the item is rotated, but looking at the very top of this shape, of this pentagon, we can see the text placed on the top left. In the example O, it's roughly the same, alright? And maybe the last one, when rotate label is null and configuration is K, then we should expect the text to be visible above. Let's go with example K, and the text should be above, but this example is not the best because the text has been already rotated. This is another feature which I'm going to show you. But before I do it, let me jump to the offset section and show you quickly the basis, which is exactly the same as discussed in my previous text label. Rotation is defined beneath, and the principles are listed as follows. We have again several rules applied for the specific label, and let's analyze, for example, the first case. When rotate point has the rotation of 270 degrees and configuration is B or configuration is J, then the text should be rotated also at 270 degrees. Let's have a look on it. So we have point B, and our point layer is rotated from this point towards there, clockwise 270 degrees, the same as text, which has been also rotated 270 degrees. The same situation applies to point J, where the pentagon is turned around by 270 degrees, the same as its text on the top. Let's see how it looks like for this example. When rotate point has 90 degrees and configuration is H, then text should be rotated also by 90 degrees. When I take a look on my alphabet again, I will see the clear example. The point is rotated just by 90 degrees from this point to there, the same as its text, rotated by 90 degrees. How about the example above, which indicates that the text rotation should be just 45 degrees? Let's have a look on it. The rotation point is still 90 degrees and configuration is G. We should see the text rotated at just 45 degrees. But if I go to the example G, I will see that text is rotated more than 45 degrees. I would say it's rather 135 degrees. From where does it come from? Namely, the text rotation comes from the top of the pentagon, which is indicated by this tip and this cable line here. Therefore, the 45 degrees falls not from here, but from there, because this is the very top of our pentagon, right? And this is how it works. So instead of 135 degrees here, we see 45 degrees. Analog situation can be found in the example 2, where rotate point is 270 degrees, and for configuration I and O, text should be rotated at 315 degrees, but it's not. When I take a look at I or O, the text rotation seems to be rotated at just 215 degrees. But going from the top of the shape clockwise this way, it will made up eventually 350 degrees. I hope that you understood it. Basically, the configuration such as this you can make on your own. You are the person who decides how the labels will be defined, and I'm giving you just an example which you can elaborate by yourself. So this is the way of how the rotation has been applied for the longest label used in our straight line diagram schematic. If I now shut it down and show you the results of the work, you will see that everything looks nice and tidy, doesn't it? We effectively have no colliding labels, no overlaps. Frankly speaking, this schematic looks even better than the PDF shown previously. However, this is a matter of preferences. We can still accept the FTTX schematic in this manner, like you see. Maybe they are quite similar to each other because the labels have been also rotated and shifted slightly away from the major axis. In our situation, also look nice and tidy. Let's change the scale slightly and browse our whole work. You can see a high level of clarity, which means that the job is ready for print. But before I print it out, we need to establish the proper scale at which the work will be clearly visible. The scale already displayed is definitely not right because the labels overlap each other. But if we change the scale corresponding to the PDF output version, which preferably is 1 to 700, then our schematic looks very neat and we don't need to worry about anything, because this scale can assure everyone that we have enough space between the particular labels and their shapes, or we have enough space between separate labels, there's no overlaps, no congestions, and so forth and so forth. That's why the scale such as 1 to 700 is surely optimal for this particular task. It's the most optimal scale for presentation in the PDF version. This is roughly the scale, or pretty much the scale. If you put 650 here, it still should be fine. If you put 100, 1 to 800, it should be still okay. But I came to conclusion that 700 is the best, admittedly, and this scale has been set as the final scale for the PDF output, which could correspond pretty much to the versions presented at the very beginning of this tutorial. Alright, so let's move to the next step. So, since we have a problem with the scale finally sorted, we can go to the next step, which is generating the PDF document from our work. Basically, if you are not savvy enough with QGIS, it can be quite significant problem, as we have quite a lot of options to set here, but everything is doable, so don't worry. The PDF document for this purpose can be generated from the printing layout in QGIS. I assume that you have some printing layouts already available in your project. However, maybe not necessarily for this type of drawing, which reflects the infrastructural location of objects rather than the map with layers itself. But I have some layouts available here, and one of them is dedicated to the straight line diagram, which have been already prepared earlier. I can use it, but I would like to explain you all of the steps of how the printing layout such as this can be generated, this particular printing template. It looks like this. You can see the output as a whole. We can make it slightly bigger and wait until loaded properly. But how to generate the stuff like this? At first glance, the format is enormous. As the project is very large, it can't fit any of paper size. Even A0 is too small for this project. Therefore, what you need to do at the very first, if you are having situations such as this, let me minimize it and create the new print layout here. If you've got the situation such as this, first what you need to do, you need to go to the page properties, and from the paper size you can select just A0, which is the biggest, but this is the stuff which you need to change manually. And let's set for the A0 right now, and for the A0 paper let's import the particular work we have. So let's import the map. It may take a while as our product is quite big, in order to show you how your job could look like in this format. So make it slightly bigger and simply import the map. By rendering this way will give us nothing, because the scale already renders just the specified section of our project. We need to go to the item properties and change the scale accordingly. So the scale is not appropriate. Instead of 144, we need to place 700. And situation has changed, but comparing to the existing layout presented previously, we can see just a third of the schematic. This is the full project. This is just of its part. So let's see how dimensions could be appropriate for the job as we have. As you can see, size must be custom instead of any format offered here. We need to set the custom one, and for the scale of 1 to 700, the corresponding width and height will be like this in millimeters. So it will be exactly over 3 meters and height over 2 meters. Sounds funny, but this is true. In our situation such as this, we have the width and height about a third smaller than in full product. Therefore, we can see just about 30% of our work. If we change it to the dimensions shown here, T1, first of all, custom, the size changes automatically, but our map stays as it is. So let it expand to the size such as this. Obviously the scale will change, but we can revert this scale to the previous one, placing 700. And finally, our project should come out as a whole. If it doesn't fit our printing area, then use this option, move item content, and adjust the border of your project to the canvas you set previously. So this is all. This is, I think, the most difficult step to encounter by preparing our work, both as the PDF version or alternatively as the printing version. However, I doubt anyone could print something like this in a traditional way. The job must be definitely split between smaller areas. In fact, you can still have the overview of your whole project in one file, which is great. Returning to our previous schematic, you can see the other features which should be inherent with the drawing we are providing, namely the title and the legend. Title is another thing, admittedly very simple thing which can be applied because we are using just the label. We need to add the label and place its border from one side to another side of our canvas. Then we can make sure that our text will fall exactly at the center, assuming that you are using the item properties here and adjusting alignment as shown here. Legend should correspond roughly to the drawing we provide. There are several ways of how we can customize the legend. I will show you just the example which is here. If you open the object and indicate the another legend properties, you will see the features such as this. You can obviously put the title legend if needed, and it will appear at the very top of this box. The most important thing here is the legend items section, which includes all the items comprising of the legend, not only for the active layers, but for the entire our drawing. It often happens that we need to select the items which we certainly need. If I switch for a while to the another print layout here, I can provide the legend by this option, add legend, and indicate the place where this legend will appear. We can see the box very extended. By zooming in, we will see all the options as listed roughly from our layers panel, which are already here. We don't want all of them. We need just these which participate on our print layout. Therefore, instead of auto update, we will switch it off and remove not needed inputs by using this sign which is minus. After the adjustment we need, we can simply have clear legend as pointed out in my previous schematic. Alright, these options are also editable. We can change the text placement, not necessarily on the left hand side, but on the right hand side. We can hide the subcategories, but this is the thing which you can learn from the other QGIS tutorial available on the web. For the time being, we can assume that everything is alright. If you are sure that your job in this section is completed, then what's left to do is export the printing layout as the PDF by using this particular icon here. After clicking this icon, we will see the default file name the same as the printing layout defined in the QGIS. So let's hit the save button, and at the very end you will be asked about some potential options of your export, but it's nothing to do here really in this specified situation. So just hit save and wait some time, because as the project is quite big, it may take a while. When everything is fine, then you will see that your straight line diagram has been exported successfully to the PDF form. In this case, we can go to our directory and see how it looks like. So this is exactly what I have exported already. As you can see, the zoom level just 20% of the true size. If I make the 100% here, then everything is clearly readable. That's obviously perfect. And this is of how our schematic looks like. Now we can back to the very beginning and see some example work which I've shown you when started of this tutorial. As you can see, the difference is really minor between one schematic and another one. Then it means that we are successful with this way of doing FTTX schematic. As you may have convinced right now, you don't necessarily need to use Microsoft Visio for creating telecom, industrial routes, and so on. You just need to use your QGIS project you're working on and simply render the necessary layers directly from there. Next, by applying the labeling and routing, you will eventually get the desired effect. So I hope that you enjoyed this very long tutorial, and if you work in the telecom industry, you will know how to prepare the FTTX schematic much quicker than usually. Thank you for your attention.